Hey, John here. I'm talking about KiCad's EDA, the Electronic Design Automation Suite today. I installed it on my Ubuntu 18.04 system by coming to the KiCad website, hitting download, and following the instructions for my OS of choice, which was this one. I did these 3 lines right here, and I got KiCad version 5, which I highly recommend you use over KiCad version 4. So if you just simply install KiCad and you get 4, back out and go grab 5. And the reason why is because the file formats for, well, actually not the file formats per se, the library organization has changed. So if you create a bunch of schematics with version 4 and you convert them to version 5, it requires a little bit of work, and if you're a beginner, it will not go well. So just start out with KiCad 5 and you'll be fine. Once you've installed it, you can start it up. I just start it like that. First time you do this, this will be blank, as you can see it right here. And you create yourself a new project. You don't have any existing ones to open or anything like that. I'm going to go over the basics here. So create a new project, find a place to put it. I save all my projects in a PC board directory that happens to be the default when I run this. I number them all like this. So I'm going to call this one 2043 example. And once you've created a project, it will create a directory and put the files in that directory. Let's take a quick peek around. I'm in my directory, my projects, PC boards directory here. I've got old projects, new ones. 2043 example was created right here, and a directory was made, and we look in there and we can see we've got ourselves the project file and a embryonic schematic and PC board file ready to go for this project. Okay, get that out of the way, get this out of the way. Schematic. So the first thing you want to do is do your schematic capture. I'm going to just show you how to go about that. Presumably you have an idea in mind. You might want to pencil sketch it out on paper before you start drawing it up for real. Editing a schematic and moving things around can get messy, so I suggest you plan. First thing you want to do is make sure that all the settings are correct for what you want to accomplish. I'm in the US, so I'm going to choose this kind of icon up here, which has to do with the page settings, and you can choose the size of the page you want to draw, any old standard size or even a custom size available. I'm going to choose letter, nice small thing that I can print out on my printer. And what you're doing here is filling out the values of this guy down here. This is called a title block, and these fields in here are mapped from these values here. So if you hit this triple left thing right here, it'll put the current date in there, which is fine, so you don't have to type it in. This is revision 1. Title is an example for John's basement. If I can type that correct, that looks good enough. I'm going to just type in these, if I can spell, things to show you where they go. There's comment 1, comment 2, comment 3, comment 4. Okay, there we go. Okie dokie. Now I'm using my mouse wheel. I move the cursor over an area that I want to see in detail. Like, let's say I want to zoom in right on this box corner. I move the wheel forward. I move the wheel backwards. So just so you understand what I'm doing when I'm zooming around. When I'm panning, what I'm doing is I go to some place I want to grab, and I press the middle mouse button, which is my case the wheel. I push the wheel down, and I can grab the sheet and I can push it around. If you don't like doing this, you can obviously grab these scroll bars down here as well, and the one on the side like this. All right, so let's zoom in on the title box here, title block. The values I filled in, as you remember, see 1, 2, 3, 4 kind of go backwards in this top area, and the company is bolded on the bottom of these lines. These are created automatically by KiCad. I'm in the root sheet. If I had a multi-sheet project, they'd all have separate names that would look like paths. And the actual file name is put in here. The title that I typed in is put right here. The date that I put in is here. The sheet size and version of KiCad is added by KiCad. My revision 1 goes here, and this is the page number. All right, so that's how you get your title block set up for your new project and your page size. These guys over here on the left, the grid, we don't need to talk too much about the grid. It's basically like, this square matrix of all these dots. I don't know how well that will show up in the video, but that's a snap to a line kind of a grid. Do you want to deal with inches or millimeters? It's your choice. In schematic entry, I don't usually care about dimensions. That's more important when we're designing a PC board. Who cares? Use the defaults whenever you can when you're getting started, so you don't get too confused. By the way, that's generally a good idea. What is this guy? Any angle. This means you can draw, wires on angles and things. Generally, that's not done. So just leave these set the way they are in the defaults. This one actually, the way this thing works, by the way, it says draw them in any direction. That means if I click this, I'm enabling what it says in there. So right now that's off. If I click it, now it's drawing in any direction. If I hover over it, it'll say on buses, draw horizontal and vertical only. So what the pop-up help is telling you on these is what will happen if you click it. All right, so don't get disoriented on that. Okay, so what do we want to do? We want to put components down on here, and we want to draw some wires between them, right? Okay, so the first thing you want to do, this whole grid thing, you'll find out pretty quick that the symbols that they give you require you to have your grid set to 50 mils. I think this is the default. This is a little more esoteric. Don't mess with this thing. What I'm doing here is I just hit the right mouse button to open this menu. I come down here to grid just to see what it's currently set to. If you don't set it to 50, you will have drawing problems. That's why I want to point this out. Just set this to 50 and ignore it for now while you get acquainted with all these values. All right. So let's talk about how to put things down and wire them up. That's the whole point here. So this down here is the symbol icon. If you click that once, you'll see it gets highlighted. The cursor changes to a pencil like you're going to draw something. So I'm going to left click here, and it opens up a box that lets me choose from many things. So in this box, we have these little pop open menus, the 4000 series MOS chips, 7400 series, and so on. You can pick the kind of things you want to place, generic connectors and so on. If you click on one of these items in here, it'll give you a little picture of what it's going to put in your schematic. When I use these connectors are like the headers, like a Raspberry Pi header, a row of pins. These are the ones that I tend to use. Let's just put down a header with 10 pins on it for fun. So I've selected that. I hit OK. And now I've got a part stuck to my mouse. I can left click right there to put one there. Notice I'm still in a mode where I'm placing components. If I click again, it'll open the editor. I can go ahead and hit OK again and put another of the same part, or I can hit escape and watch what happens in the upper right here. The mode changes. We no longer are placing symbols. We are back in regular cursor mode. All right, so how do we put normal parts down here? I select symbol. I can search forever, or I can just type in what I want to see. Like I want to see a resistor. Well, this is all the things that are described as resistors in the library that comes with KiCad, which is fairly extensive. It's very useful. The one I use is this one. It's just called R. You have a small one, you have the US style, the kinky line, and so on. The regular old generic resistor is pretty reasonable, especially for beginning schematic, for all schematics, for reasons I'll explain in a minute. So there's a resistor. Let's say I just left click again. I want to put another part. I want to put a capacitor. You start typing what you want. You have various things. There's a small one. The C, just like the R, the generic capacitor, unpolarized, is just a part named C. Let's go ahead and see what these other ones are. No device. Okay. See small, there's a small one, a regular one, a polarized one. This is one style of polarized capacitor. Well, I grew up looking at this style in schematics that I saw drawn, so I tend to place these ones down. Whatever the one is kind of a personal preference on the style of presentation. So you choose what you want. Let's go ahead and put an LED in here as well. You can have a hollow looking one like this, or you can have this one here, which is more akin to what I'm used to seeing. They've got all kinds of other ones as well, various different packaging and types of leads. For a generic single LED, this is the one you want to use. So I will now hit escape, and we've got a bunch of parts on our screen. Okay, great. How do we wire these up? Maybe I didn't put them exactly where I wanted them. If I go over and hover over one of these and press the key M, it will grab onto this part and I can move it around, just like I did when I was originally able to place it. Now, while I'm holding it and moving it around, notice I can move my mouse wheel in and out to zoom while I'm hanging onto this part. Maybe I want it over there. And I hover over the LED, I move that around. Maybe I want to put it up here. Left mouse click to drop it, M to move it, I want it over there. Oh, suddenly I remember I want another capacitor, another polarized. If I press C, I am copying something that the mouse is hovering over. I go over the LED and hit C, and now I make a copy of that part. So now I can create, clones of things. Hover over it and hit M to move it. Maybe this capacitor needs to go over there. Move this resistor over here. Okay. Let's say you don't really want this resistor vertically, you want it horizontally. If you hover over it and hit R, it will rotate. Okay, so I can rotate it, hit M to grab onto it and move it. Maybe I want to put a couple of resistors over here, C. Now, if you're going to put a lot of them next to each other, you need to leave room for the description of the part. So maybe I'll copy it again, and maybe I need to put a third one up here. You'll notice we start running out of space. This is one of the problems of drawing schematics. Let me zoom in a little bit, see what's going on here. Now, one of the benefits here is I can go over this part. Remember, these are part of the, let me hit M here and get it out of my way. So each one of these parts has an annotation, like the part number. This would be like R101, R102, R103. This field that says R in it right now will be the field that shows you the value, like 10K or something. Now notice when I hit M over a resistor, I move the resistor and the associated fields that describe what it is. If I hover over just the R and hit M, I can move the value field wherever I want. Now this is why I like these resistors, because you put the value inside the resistor itself, which saves you space. If I hover over just the R question mark, you can now grab that and move it around. So if I say move this into the middle of there, move that guy down here, move this one down like so. Now I can move this in here, and you can see where I'm going with this. Move this guy down here. Now it's easier for me to place a higher density number of resistors and pack them in. Now that I've rearranged these symbols on this resistor, if I type C to copy it, it copies it with the rearranged values too, which is pretty handy. These guys, once you get them arranged, you can start cloning them like crazy. Now, even as it's drawn right here, if I connect a wire through here, I will be running it through this, the notation, the value, the enumeration of this. So sometimes I might move these over to the side like this. If you really need high density stuff, this sort of thing helps a lot. Okay, now I can connect all these wires up without going through these names. And maybe I want to move it, over to the left. Now, notice I'm over the R. When I hit M to move it, it doesn't know whether I want to move the value or the symbol in its entirety. So this is a good example of these clarification menus that come up. When you get stuff on top of each other, it doesn't know really what to do. So if I hit M and I'm over more than one thing, I get this menu. If you decide, I don't want to do that, remember, escape, 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 escape. I'll always get you out of whatever it is you're doing right now back to the generic default mode. If you type M over here, it's not ambiguous. You're grabbing the part and you're going to move that. Okay? I moved these to the left because when I fill these numbers in, I don't want them to run over and write on these other parts. Okay, so now what about the wires? Well, how do we draw these wires here? Okay, let's say we want to just connect, move this over here. Remember, we can rotate with the R, and I can do that while I'm moving. Let me zoom back in, get like a visual alignment. Maybe what I want to do is draw a schematic for a board that just has some resistors and headers on it. To connect wires, you go grab this green guy, not the blue one. That's a bus. That's several wires. You want to draw a single wire. That's the green one. You go grab one of these little terminals and you click left mouse button, left mouse button. You just created a wire, left mouse button, left mouse button. That's a wire, left mouse, and so on. Left mouse, left mouse, left mouse, left mouse. And this is all there is to it. Put parts down, draw the wires between them, wherever they're going to go. Maybe this one goes like that, and so on. Maybe you want to say left mouse here, and as you draw, you get these, you can see it's trying to figure out, do I want to go right and then up, or do I want to go up and then then to the right. If you want to force it to do something in particular, if you hit the left mouse button like right now, what it has done is it has nailed down the point that I clicked on, so it will not help me anymore, unless of course it can't. I mean, you can get it to wake back up again, as you can see right now, but for the most part, if you click, it's going to stay there. All right, then you might want to come over here, and maybe you want to go up here, and then you want to come back. Well, you know, it's trying to be helpful, but you don't want it to, so you're going to go like that and click it right there and say, don't go to the left yet. I want to go up and around and go to this LED like this, maybe. Okay, so I'll click on that terminal. That's how I draw that wire around there. Maybe I want to draw this one over to the left a little bit. I click right there, left mouse button, come down, and then I want to go to this terminal, but I don't want it to be that close. Maybe I want to come down over here. Click right there, left mouse again to connect the wire to the end. All right, if you connect two wires together, I just left clicked on that terminal. I'll bring the wire down like this. If I click right there, I'm connecting the two wires together, and in the standard notation, if there's a dot right there, those wires are connected. If on the other hand I say grab a wire from this LED and I come cruising down here like this, and I click left here, and then I click left to connect it to 6, these wires cross without a dot. Those wires are not connected. As always, hit escape and watch over here, and you're no longer placing wires. So there's how you place yourself some wires. Now, let's say you don't really like the way this looks. These wires are too close together or something like that. If you type M to move this, you're going to move it, and it's going to disconnect it from these wires, which might not be what you want. If you accidentally move something and you say, oh no, I don't want to do that, I want to put it back to where it was, just hit escape and it'll abort that operation. If instead I did that on purpose so that you can see what the difference between M and G is. If I say G while I'm on that LED and I move it around, you'll notice the wires stay connected. Now, normally you don't want to move it like that with angled wires, but maybe you just wanted to move it a little bit to the left. All right, done. Maybe this one too. You want these to line up. Hit G up here, slide that a little bit to the left, and you're good. Okay? You might even want to move this wire over here. Hit G on the wire itself, and you can slide that thing over to the right. Okay, things like that. That's what the M and the G are for. All right. To number these parts, now that I've got a bunch down here, well, which one's C1 and C2 and R1 and R5, and how to get the values in these. If you hover over a part and you hit E, you get the properties editor. The reference is the thing that you use to say like R1, R2, R3, and so on. The value might be 10K. All right, so now R1 here has 10K. This one here, I'll come over here and hit E. I think if you hit E right in the middle, it'll once again clarify whether you want to edit the one field or the entire symbol. Maybe this is going to be R2. And his value will be 20K. All right, and so on. Edit this one. Maybe this is 30K. Now some people type 3K, or 3K3 or whatever. Use whatever notation you want to use. Just be consistent whatever you do so people understand how to read your schematic. Come down here, maybe this is a 1K. Alright, so now these are labeled. The same thing, you can go around and do all the rest. Now sometimes you need to have power symbols. These are just symbols like anything else. Maybe you want to connect these capacitors to ground, okay? There's a little ground thingy here, which is really another way to open up the symbol editor. Again, you see the little pencil, it wants to do something, left click, and this is going to open up the symbol chooser, but only give you the items related to power. Now, P-Spice is something else. You want to use the power symbols. Now, do you want a 10 volt or a 15 volt? What do you want to put in here? I want to put a ground. There's so much stuff in here. I'm going to just type in GND. All right, this is the one that I want to use. There's many different kinds. They all look different ways. You choose the ones you want to use for whatever it is you're going to place. I'm going to put a regular guy like that. I'm going to hit escape because I'm done putting symbols. I'm going to grab a wire. And I'm going to hook these guys together. I don't know if they're in line. Yeah, they are. Okay, so I can hook all three together in one shot. I can left click there, left click here. Maybe these two get connected like this. I don't know. Hit escape. I'm not placing wires anymore, so now I have a ground. Maybe I want to put a 5 volt power on here, right? So I'm going to do this again, and I'm going to say I want 5 volts, please. This is called a power flag. All right, I'm going to say this is supposed to be 5 volts. Hit escape. This tells the schematic editor what the voltage is supposed to be there. The fact that it's a power supply line. This line, this net, they call that a net. Each one of these wires here is called a net. And it defines the purpose of that net. All right, so that's how you enter schematics and place parts in KiCad. If you want to print it out, well, I guess you want to save it first. That's this guy up here on the left. You can print it out by clicking print, and you can preview and use all the usual printer stuff. I'm going to hit escape because I don't want to do that. You can also say plot it. You can plot the schematic and make yourself a PDF and the size of the sheet, and I want to make it color with the borders and all that other fun stuff. When you pick the directories and whatnot, I find it much more convenient to use a relative path. And as you can see, when it pops up a little menu here, it says you can put a full path in here, or you can use a relative path, which is what I've just done. Put it in the same directory as the project, plot all the pages, and you see it says it did it and it's okay. When I click this, you'll notice something appeared in this box over there. That's the PDF. It's in the project directory and associated with the project. So the project manager now shows it as one of its items. Oops, I can't open it because this window is still open. Close that window. Open up the PDF. And now I'm just in a regular old PDF browser. So you can see it here. You can now have a PDF file here. Email it to your friends, post it on Facebook, or whatever you're going to do. So that's all there is to schematic capture, as long as you use existing parts in their library. In future videos, I'll show you how to create your own parts and draw PC board foil traces and all that other fun stuff. If this is useful, give me a thumbs up or give me a comment. Let me know. I'll talk to you later. Bye.